Oh, hello class. It's Sai. Well, before we start the lesson today, have you guys all checked the Schoology page? Schoology page should have more information on what you must finish today, since Miss Chang will not be with you today. You can check your quiz scores as they have been updated on PowerSchool. Please check. Also, before today's lesson, please be sure to go on Schoology and do what's asked from you. Sorry, I'm not used to the classroom. I'm used to the stage. Please go on to Schoology and watch the keynote and take notes on Trig Identities basics. And there's about 7 or 8 examples on the basics of trig identity. Be sure to do that before continuing. I'll see you soon. Bye. Math, okay? So okay, Ms. Chang. Welcome to class, guys. Alright, you saw the school already? Let's get started, okay? Well, I think Ms. Chang might be coming back actually, because honestly, I'm just Sai. I know how to dance and sing, but I don't really know the math, okay? So, okay, Ms. Chang. Hey, guys! Welcome to class. I forgot to tell you that I won't be here today because I'm at Eco Geo with my freshmen. So I'll just be doing the lesson this way. I hope you watch the video and you actually stop when you need to stop and process. Rewind if you need to rewatch, okay? Alright, well, I'm a little nervous because this is the first time I'm recording myself. I don't know how I look on camera, so please forgive me. Let's get started. You have all your trig identities written down and you should have it in front of you, okay? Alright, here's the first example for you. I saved all the more difficult examples so we can do them live together, okay? Here we go. Hi guys, ready for the lesson? Let's go. Alright, so I'm going to show you a few more examples with the more difficult cases for trig identities, okay? Using trig identities. Remember, you only need to really remember just one trig identity, sine squared theta plus cosine squared theta equals 1, and everything else is actually derived from that particular one. And you saw the actual proof of that in the actual keynote, okay? Alright, if you haven't got that yet, make sure you watch that first. Alright, here's the first example. Alright, we're going to do simplify. Simplify this little sucker, 1 minus sine theta plus 1 times 1 plus sine theta. Alright, well you can already know that you have to actually FOIL it or distribute it in. So here's what I'm going to get. I get 1 squared minus or plus sine theta minus sine theta. All I'm doing is distributing, right? And then I get minus sine squared theta. And what happens here is, hiya, these go away, so you're left with 1 minus sine squared theta. Oh my gosh, isn't that part of the trig identity? Oh yeah, the Pythagorean identity. Remember the Pythagorean identity is sine squared theta plus cosine squared theta equals 1. Alright, so you know that it's going to be, how is that formed? It's because we subtracted sine squared theta from this side. So we're left with cosine squared theta. Alright, and that's your solution. You've now simplified this long thing just to that. Alright, example 2. If you didn't get that, make sure you rewind it and watch it again and you really understand what's going on, okay? Again, maybe I should note this. This is actually the Pythagorean identity. Because that's what your book's calling it. Alright? Alright, example 2. Here we go. Example 2. Simplify. You gotta simplify this sucker here. Alright? Now I want you to recognize this here. Secant theta could also be written as 1 over cosine squared theta. Or we can actually put this guy up. So this could be 2 scenarios here, okay? Secant squared theta minus 1, or 1 over cosine squared theta minus 1. Because secant theta is equal to 1 over cosine theta, okay? Now, you look at this scenario and you're like, well, which one actually has some sort of trig identity that I can actually use? And you notice, ding, 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 secant squared theta minus 1 is actually from trig identity. From trig identity. I guess if you look at my notes, it's actually trig identity number 2. Take a look at that if you have to, okay? Take a look at it on your notes. You should have written it down. So now I get that, which is actually tangent square theta. Because trig identity number 2 goes something like this, right? It goes secant square theta plus tangent square theta is equal to 1. So I just subtracted secant square theta from there. All right? That's example 2. Simplify all this, it just becomes that. All right? You guys following along okay? All right. Let's go to example 3. All right, example 3. Welcome back. Here's example 3. All right. Cosine squared 50, sine squared plus sine squared 50. I don't know if you recognize this, but isn't this really cosine squared theta plus sine squared theta? And you all know that's actually the Pythagorean identity, which also just equals 1. Right? That's easy. All right, let's go to the next one. Example 4. Simplify cosecant squared theta plus minus cotangent squared theta, or t. Sorry, cosecant squared t minus cotangent squared t. All right? Well, let's see. You gotta think, oh my gosh, like, how can we write this so that it kind of looks like this? You have to think about all the trig identities. There's only really 3, and then see which one you can use to actually simplify this the best you can. So in this case, you're like, cosecant squared theta could actually be written in terms of cotangent squared theta somehow. So I'm going to be like, oh, I could use trig identity, right? Trig identity number 3. And trig identity number 3 look like this. Cotangent squared theta plus 1 equals cosecant squared theta. Remember that? If you don't, look on your notes on the keynote, okay? Or you should have written this down in your notebooks. All right, and then you're like, wait a second, cos squared theta t is actually cotangent squared t plus 1. That whole thing just becomes this. And then you subtract cotangent squared t because of that. And when you actually simplify that, what happens is these two just drop out. So you're left with uno. And that's simplified. All right? All right, make sure you understood that. If you didn't get that, make sure you guys go back or ask each other. Be helpful, okay? All right, let's go to example 5. Here we go. Whoa! It looks much more difficult than it actually is, okay? Don't fear. You can already see that 1 minus sine squared phi, or phi, okay? 1 minus sine squared phi, phi, okay, is actually, can we actually rewrite this as 1 plus sine phi? Oh, sorry, that's another way of writing phi, okay? 1 plus sine phi times 1 minus sine phi all over, remember these are packages, 1 minus sine phi minus 1. So what you're left with, hiya, hiya, right? You can do your karate chops here, and you're left with 1 plus sine phi minus 1. And then, hiya, hiya, you're left with sine phi. And that's your answer. Easy peasy. We haven't hit the hard ones just yet, okay? So you're going to be working on only the most basic cases today until I return Wednesday, all right? So you guys good? All right, let's go on to example 6. Again, if you didn't get this, make sure you guys go back and try all the simpler examples and look at your notes again, all right? But now, I'm going to go on to example 6, our last example, but you're going to need this one first. So I want to explain to you something. So this is actually example, problem number 25 on 13.6 on your page 639. So you'll see that they ask you to write secant x in terms of sine x. So that means we don't want to see secant anymore. We want to see it in terms of sine x. We only want to see sine x in your solution. So what we do is very simple. So you know that 1 over cosine x is actually secant x, right? So we all know that. So we're going to use a trig identity, all right? So we know this fact already too. Sine squared x plus cosine squared x is equal to 1. Now, if we actually subtract and solve for cosine squared x, we get cosine squared x equals 1 minus sine squared x. Now, if we simplify that even further or reciprocate it, we get this. 1 over cosine squared x is equal to 1 minus sine squared x. Now, we want to solve for cosine x, 1 over. See how they almost look alike? These guys almost look like same, but different, okay? So you guys, what we do is we square root both sides, and here's what we get. And we get, finally, we get 1 over cosine x is equal to plus or negative 1 square root of 1 minus sine squared x. And we leave it like that. I know you're tempted to rationalize this, but you just leave it like that for now, okay? So really, if I say 1 over cosine x, it's actually equal to this little sucker here. But that means secant. Isn't this actually secant? So secant x is actually equal to plus or negative 1 over square root of 1 minus sine squared x. Now, I guess now you could already assume what I'm going to do next. If secant equals this, that means cosine is equal to actually this, and also sine is actually equal to this. Now, please write these down, because you're really, really going to use these for your homework assignment tonight, okay? So write this. Sorry, my finger. You can't see my finger. So you got to use secant x is equal to plus or negative 1 over square root of 1 minus sine squared x. And you have to also use cosine x is equal to plus or negative square root of 1 minus sine squared x. Sine x is equal to plus or negative square root of 1 minus cosine squared x. You guys see me spit? Sorry about that. You guys good? You're going to need this, so write this down and stop the video, because I'm going to actually show you the example that's going to utilize this, okay? All right, ready? All right. So final example for today is going to be this, because we're going to actually continue trig identities when I come back, all right? So you guys, we're going to do this first, okay? They want you to write the following function, for example, tangent, that's alpha, secant alpha, in terms of sine alpha. So all you do is this. You ready? So you remember all your facts, okay? So I'm actually going to write this sucker in terms of sine alpha over cosine alpha, because you know that tangent alpha is sine over cosine. And then I'm going to write this as this, 1 over cosine alpha. All right? But right now I still see cosines, and I only need to see sines. But you know that cosine alpha, from the previous example that I just showed you, that you know that sine alpha stays, because that's what we wanted in terms of. Okay, we only want to see this in the answer. The cosine is actually plus or negative square root of 1 minus sine squared alpha, right? And it's times 1 over plus or negative square root of 1 minus sine squared alpha, right? So we wrote the cosine in terms of sine, and that's what it looks like. And then what happens here is, what happens? Well, when you take a multiply 2 square roots, it comes out of the shell, so it just becomes sine alpha over 1 minus sine squared alpha, and this is our final answer. All right? So you guys, your assignment for today for Trig Identity Day 1 is only 13.6, page 639, and I think it's worth doing a lot of the practice. So it's 1 through 24, all. All right? Try this, you guys. Good luck, and holla at me if you need anything, all right?